Good afternoon, everyone. This is Gene Bohensky at Exothermic, and the title of this presentation is going to be a comparison of reaction injection molding with other methods. So we're going to start off with that. We're going to first introduce exothermic molding, and we're going to talk about what is reaction injection molding for those who don't know. And we're going to compare reaction injection molding with other methods. And then we're going to introduce you to the Proxima material and our other services. So let's start about exothermic molding. So we were founded in 1971 with a business plan to provide reaction injection molded parts to the medical, electronic, and lab instrument markets. This year is our 50th anniversary in business. Our headquarters is in Kenilworth, New Jersey. On the right there is a picture of our facility. We're committed to innovation. We're continually making investments in technology, equipment, and in our employees. It's one of the reasons why we've really been at the forefront of the industry in innovation for rim molding. And our mission is to provide the highest value reaction injection molding services available. So there's two basic types of plastic molding that we want to talk about, thermoplastics and thermosets. So thermoplastics really in general are where you have hot plastic that is heated into hot molds, and that plastic goes into the mold. The plastic is taken out of the mold, it is cooled, and it hardens. Those include plastic injection molding, structural foam molding, and vacuum forming and thermoforming. Thermosets are a little bit different. Typically with thermosets, we take a combination of two parts, we bring them together, and the reaction of those two parts, two liquid parts, creates a solid through the chemical reaction. Those types of molding include reaction injection molding, which we'll be talking about, urethane casting, and fiberglass molding. So those are the two categories, the thermoplastics and the thermosets. Let's just start with what reaction injection molding is. It's a unique process that uses the reaction of two liquid thermosetting polymers. So you could see on that diagram on the right, you have the isocyanate in tank A and the polyol in the day feed tank B, and we're bringing those two together. The reaction is done really at room temperature. The mold is kept at room temperature, typically in an aluminum mold. And the reaction of the two chemicals together, of course, gives off heat. That's why it's called exothermic molding. It's an exothermic molding process, and that after time, the two liquids form a solid. There's a couple of really important benefits to this type of molding method. You have a lower mold cost, which is ideal for low volume and complex parts. And it creates strong and lightweight parts that are suitable for painting. So a lot of the times the parts are used as really outsides of enclosures or for visual purposes. The molding method is extremely cost-effective for specific applications when compared with standard injection molding. That's basically because the tooling cost is less and it's easier to get a more complex shape. You can also encapsulate electronics due to the low molding temperature. This is a problem when you're trying to do injection molding with hot plastic. You typically can't use electronics or mold around electronics because you'll destroy the electronics. I've seen that in a number of applications where it isn't possible. Because typically electronics don't like temperatures above 150 degrees Fahrenheit. So let's look at some of the other molding methods and how they compare with reaction injection molding. Let's look at plastic, just regular plastic injection molding. This is a common manufacturing process for producing high volume parts by injecting molten thermoplastic material into the mold. So let's start with the advantages of injection molding. On the right, you have a lower high volume per part cost. So for every time you're looking at high volume parts, plastic injection molding is the way to go. You can also make the parts out of various plastics and add colorants. And so you have colored plastic parts. You can also have fine part detail and a much greater range of material choices than reaction injection molding. The advantages of RIM are that you have much lower tooling costs for low volume parts. So if it's under 500 parts a month, typically the tooling is a lot more expensive when you have to amortize that over a lower amount of parts. You also can get varying wall thicknesses on the same part, which is a big benefit for RIM. And so in a lot of cases, you can put together multiple parts into one part that you have to do with injection molding. There's also much shorter tooling lead times, especially when you work with our company, because we have internal mold making capabilities in-house. It also produces high strength, large parts, and again, safe encapsulation of electronics, which is not typically possible with regular plastic injection molding. Let's go to vacuum forming or thermoforming. This is where a plastic sheet is heated to a pliable forming temperature. It's formed to a specific shape in the mold and trimmed to create a usable product. The plastic sheet is transformed into a three-dimensional shape by using heat, vacuum, and pressure. So thermoforming advantages is that it's less expensive for simpler parts. Again, no paint needed for single color parts because you can get the plastic sheet in multiple colors, and generally less expensive tooling. RIM advantages are that you have much greater design freedom, where you can design a lot of complexity into the part. You have much lower costs for complex parts, higher part tolerances, also thicker and stronger parts. And again, the ability to encapsulate bosses, ribs, and other 3D features that are not possible with vacuum forming or thermoforming. Next up is structural foam molding. This is a process where the addition of a blowing agent and modification of process parameters creates a sandwich construction that has a solid skin on the outer layers and a foam core in the center. Okay, so advantages of this type of molding method is that it's good for thicker walls if you have really large, thick walls that you want to put into your part. It may be somewhat cheaper for medium volume parts. You have a reduced weight because inside really you have more solid foam than solid plastic. It's also very good for heat insulation. Advantages of RIM compared to structural foam molding include, again, lower tooling costs for low volume parts, that is less than 500 a month, much shorter tooling lead times, higher strength large parts, and more variations of wall thickness in the same part. So always a hallmark of RIM. Let's look at cast urethane, which is in some ways similar to RIM molding. This is where a liquid polyurethane is dispensed into a mold, post-cured in ovens, and if required, secondary machining operations can be added. Offers many of the advantages of RIM, including design freedom and encapsulation. It's often used for prototyping. So particularly with very small quantities of large parts, or when you're doing prototyping of parts, the advantages of cast urethane are that you have a very low tooling cost for small production runs, that is 25 or fewer. The rubber molds are half or less of the cost of RIM molds. So you have a much lower rubber mold cost. And it may allow more difficult features as the part can be peeled away from the soft mold. In many cases, we've seen that the replacement mold may be in the cost of the parts. That is, a lot of the companies offering this, they have a kind of like a mold for the rubber mold, and then for a pattern for the rubber mold, and then when they need to make new rubber molds, it's not that as expensive, so they just roll that into the cost of the parts. So advantages of RIM are that we have an unlimited mold life versus maximum 125 uses for cast urethane. RIM also produces stronger parts, and more variations of wall thickness in the same part are available. Parts cost about half of what they do with cast urethane, so there is also a part cost. The big benefit here is also the amount of parts you can make per shift. So with a large rim part, you can do 50 parts per shift versus 2 parts per shift on a cast urethane part. And that's actually a very mechanical and difficult process that is a very manual process. And you get better material properties, particularly with our new Proxima material, which we'll talk about a little bit later on. But the material properties are better with the rim parts than they are for cast urethane. So if you're looking for small quantities of large parts, then you want to look at rim. Let's look at fiberglass molding. This is a process in which fiberglass reinforced resin plastics are formed into useful shapes, typically a labor-intensive and manual process. Advantages of fiberglass is that it's good for large parts, for prototyping of large parts, and you can also encapsulate metal parts. It is a very manual process. They've tried for years in auto production to try to make a volume fiberglass parts, not fiber optics, fiberglass parts, and it's been very difficult to do. There's been a couple of manufacturers that have done this, but they've never been able to get over the intensity of the process. So advantages of rim over fiberglass is that you have much shorter tooling lead times. Tooling can be used for low volume parts. It's more environmentally friendly, no hazardous styrenes that are typically given off on the fiberglass production, and much shorter cycle time, 2 to 3 minutes versus hours. Again, this is similar to the cast polyurethane issue where you can really only make a couple parts per shift versus with rim you can do 50 or more per shift. So let's look at aluminum die casting. This is a process where aluminum is molted under high pressure in the mold cavities to form cast parts. This, of course, makes metal aluminum parts, which has those advantages, which they're stronger metal parts, they're low part cost and low tooling costs. Rim advantages versus die cast aluminum is that you have greater design freedom, especially with detail, much shorter tooling lead times, lighter and less expensive parts, safe encapsulation of electronics, better surface finish, and no machining required for the final product. That's usually what you need to do with a lot of die-cast parts, is you need to machine them, you need to paint them, and dress them up a bit. Let's look at sheet metal. Sheet metal advantages are that parts can be structurally stronger, no EMI or RFI shielding needed, especially if you're looking to comply with that CE, that electromagnetic compatibility directive, less expensive tooling, and lower expense for simple parts. It's easier to make simple parts out of sheet metal. The rim advantages is that you have much greater design freedom. It's less expensive for complex and curved parts, and the ability to combine multiple sheet metal parts together, which is what we often do with rim, is you can combine many complicated parts into one part. Generally, the parts with rim are lighter weight, and you have enhanced sound and vibration insulation. Again, encapsulation of electronics and other parts possible, and it's also corrosion resistance and non-conductive. So here's a general table overview of rim versus a lot of the other parts forming methods. This is found in our website, but in general you can see rim really has the ability to do a lot of things. You can mold in outside features, inside features, you could mold in stiffening ribs, create variable wall thicknesses, encapsulate metal, encapsulate PCBs and electronics. It's appropriate for large parts, complex geometry, reducing parts and assembly, low production volumes, We have short tooling lead times. We can create structural parts with rim and with excellent part-to-part repeatability. We also have low unit cost, low cost molds, and low cost mold changes. So really, it's a great overall method for many different types of parts. But what we think is going to revolutionize rim molding is this new material we've been working with called Proxima. And Proxima has a lot of advantages over the standard materials that have been used for rim for many years, for the last 50 years. Has many benefits. It's a Nobel Prize-winning thermoset technology that is superior to polyurethane in almost every way. Proxima is a registered trademark of Materia that is the supplier of the product to us. It makes lightweight, stronger, and tougher parts with better thermal properties, and it's a drop-in replacement for the standard rim materials. That means you could take your existing tooling and run the Proxima material in it instead of the other material, and you're going to get better parts. And you can design new parts with properties that are not possible with rim. So let's talk a little bit more about Proxima. It's a groundbreaking advanced polymer technology based on dicyclopentadiene, DCPD, and the family of copolymer. Proxima thermosets derive their unique characteristics through a polymerization reaction enabled by a proprietary Grubbs catalyst technology, and that's what was given the Nobel Prize. It's formulated to address high-performance applications unmatched by many of today's competing materials technologies. So when you take a look at this material versus others, you have excellent corrosion resistance, and it approaches the corrosion resistance of the fluoropolymers like PVDF, which is very good. It's very abrasion resistant. You have extremely high impact strength. It can also almost be used as a ballistic material, and you have high use temperatures. So again, it has exceptional toughness, high impact strength, and resistance to crack propagation for long-lasting parts with predictable life cycles. Parts are basically unbreakable, and this is important. They don't fail by cracking. It's a very tough material. It's also lightweight. Densities near 1 gram per centimeter, a cubic centimeter, are 10 to 15% lighter than comparable thermoset resins. It has excellent hot-wet properties, extremely low water absorption of polyolefins combined with the thermal stability of thermosets as opposed to polyurethanes with a much higher water absorption, and that is also a big advantage. Low carbon footprint, cradle-to-grave emissions are 47% lower than epoxy resins. And the resins are low viscosity, quick molding of complex shapes, high filler loadings, and low void content possible as low as 10 centipoise on the viscosity. So let's look at the different applications that we have for rim and for Proxima. Our big ones are housing and covers for medical device, laboratory, and scientific equipment. We have structural components with a high quality finish requirement. There's some examples. And there's one interesting example that was never possible before, which the Proxima material has very exceptional mechanical properties which allow the material to be used in applications not previously possible with rim, including being used for a wheel, which is currently undergoing testing, wind turbine blades, robotic parts, or aircraft train and automotive structural parts. So this is something that is pretty unique, and we think there's a lot of life left in finding new applications for the Proxima material. Now, Exothermic has a wide range of materials that I'd like to talk about. We can assist you from design concept to final production, including mold making. We also have 3D printing capabilities on site to help you with prototyping. So we're well adversed at helping our customers develop their product designs and help them put them into production. Here you can see our area where we sand the parts. A lot of our parts require a very good surface finish, so our staff are trained with a high attention to detail to make sure the parts come out looking good. We also have our internal paint booths with an automated grade finish available. And then final finishing to make sure our parts look great. And there's some examples of that. Here's some more examples of our parts. Now I'd like to play a video for you, but I'd like to share the sound of the video. And this is a video that is showing the advantages of rim molding. And you should hear it. If you don't hear the video, please let me know in the chat. I did turn it on so that you can hear it, but sometimes there's issues with these computer settings. So here we go.
Of reaction injection molded parts, Exothermic continually invests in new processes and cutting-edge technologies. Introducing a Nobel Prize-winning formulation that is setting a new performance standard in plastic parts. Look at what happens when we test the strength of regular plastic parts. Look at the difference when we test our new material.
Hi, I'm Paul Steck, president of Exothermic Molding. Exothermic has been performing reaction injection molding since the 1970s. What we're showing you today is a new revolutionary material for its toughness and durability. We drove over the molded part with a truck. We hit it with a sledgehammer. What you can see here is evidence of its survivability. We even hit the parts with a tamping bar, and you see that the bar broke before the parts broke. We think this is an important advancement for material properties in rim molding.
Stronger, lighter, and more durable plastic parts. This is the perfect material for plastic enhancement or metal replacement for low quantities of large complex parts. Call Exothermic today or log on to our website to learn more. As a leading
So thanks for your time. And now we have time for your questions. I'll just put everyone can ask their technical questions. We have some people online that can answer them. We have some specialists here that are also in the webinar. So if anyone has any projects that they're working on and questions that they have about whether rim molding is the right choice for your project, let us know.
I got a question. Thank you very much, Gene, for the presentation. I was wondering, are these materials UL listed?
We'll have to go check and see which listings they have.
Gene,
Yes.
they would be 94 V0 rated.
94
Okay.
V0. Okay.
Cool. And then another question I have is I work with a lot of architectural products which have very high standards for surface finish. For parts that just come straight out of the mold, what is that finish like? Can you put textures on the molds? Is there a requirement after they come out that they're not smooth and they need additional work, sanding, painting, in order to have a acceptable finish for something like an enclosure?
Yes, they would all have to be sanded, prime coated with paint, and either a high gloss finish or a textured finish could be achieved.
But that would be something post-processing, not straight out of the mold.
Not straight out of the mold, correct.
Okay, cool. Thank you very much.
So are you looking for parts that come straight out of the mold in a certain way?
No, I was just curious about what the parts are like as part of the rim process and how they go.
Now, just for your info, Proxima surface finish is a lot better than the standard rim finish. So the Proxima, besides all the mechanical advantages, would be easier to finish.
Cool. Thank you very much.
Does anybody else have any questions about a project they're working on?
No, nothing for me. Thanks.
Nothing for me at the moment, but I'll
Okay.
certainly keep you guys in mind.
Yeah, let us know. We're happy to, to
Yes, too.
quote one of your projects, and give us a chance to show you what we can do.
Okay, thank you.
Francis or Russell, anything from you?
But thank you for the overview.
You're welcome.
Okay, well, appreciate that. I'm going to jump off.
Okay, no
Thank you
problem.
again.
Yeah, we'll
Thanks.
wrap it up. Thanks everyone for coming. You can reach out to Virginia at exothermic.com with your inquiries, and we'd be happy to answer any of the questions that you have.
Yeah, does seem like a good process. Thank you very much.
You're welcome. Thank you.
Thanks. Have a great weekend.
Yeah, have a great week. It's going to be a nice weekend this weekend, so nice long weekend.
Bye now.
Take care, everybody.